You wouldn't think it, but the number of possible combinations from a humble pack of playing cards is nearly infinite. It's huge. In maths, we'll usually represent this number as a factorial, which is simply a number followed by an exclamation point. So in this case, it's 52 factorial, or 52 exclamation point. Factorial sounds really fancy, but all it is shorthand for a particular type of equation, which in this case is 52 times 51 times 50 times 49 times 48 and so on all the way down to 1. And that's all a factorial is. So the number 4 factorial is simply saying 4 times 3 times 2 times 1, which equals 24. That's all a factorial is. So back to 52 factorial. It's a really long number. Like, it's 8 times 10 to the 67th power. That's 8 followed by 68 zeros. That's a lot of different combinations. A young guy named Janne Kaiken really elegantly described it as this. Any time that you pick up a well-shuffled deck of cards, you are almost certainly holding an arrangement of cards that has never existed before and will never exist again. That's amazing. I've posted before about how hard it is for us to wrap our brains around numbers even as little as a billion. So I saw some really fun descriptions of how long it would take to shuffle a deck of cards through every possible combination. And here are my 3 favorites. Number 1, there are more ways to shuffle this deck of cards than there are atoms on Earth. Number 2, let's say that there are 10 billion people on every planet and that there are 1 billion planets in every solar system and that there are 200 billion solar systems in every galaxy and that there are 500 billion galaxies in this universe. If every single person on every single planet has been shuffling a deck of cards completely at random at 1 million shuffles per second since the beginning of time, every possible combination would still yet to have been shuffled. Or finally, my absolute favorite description by a gentleman named Scott Cheepiel. Let's set a timer down to count down 52 factorial seconds. Stand on the equator and take 1 step forward every billion years. When you've circled the Earth once, take a drop of water out of the Pacific Ocean and then circle the Earth again. Keep doing this, and when the Pacific Ocean is empty, lay a sheet of paper down, refill the ocean and carry on. When your stack of paper, remembering you're taking 1 step forward every billion years, when your stack of paper reaches the sun, have a look at your timer. The left 3 digits on the timer won't have even moved. There's barely any change. You'd have to repeat this process 1,000 times just to get 1/3 of the way through the timer. So to kill that time, you try something else. So you shuffle a deck of cards and deal yourself 5 cards every billion years. Every time that you get a royal flush, buy a lottery ticket. Every time that lottery ticket wins the jackpot, throw a grain of sand into the Grand Canyon. When the Grand Canyon is full, take 1 ounce of rock off Mount Everest. When Everest has been leveled, check the timer again. There's still barely any change. You'd have to do that process another 256 times to run out the clock. That's astonishing. So next time that you pick up and shuffle a deck of cards, pause for a moment and think that that combination of cards that you just shuffled is probably the only time that's ever been in existence.